Hi everybody, welcome to a new tutorial. This is the first video of a new series called Machine Learning from Scratch. In this series we are going to implement popular machine learning algorithms using only built-in Python modules and NumPy. So today we will start with the k-nearest neighbor algorithm, or short KNN algorithm. The concept of KNN is fairly easy. A sample is classified by a popularity vote of its nearest neighbors. So let's consider an example with two classes and a two-dimensional feature vector. So let's have a look at this figure. So here we have two classes, the blue class and the orange class. And we have feature vectors with two dimensions. So we have x1 on this axis and x2 on this axis. And what we do here is we have some training samples, and then for each new sample that we want to classify, we calculate the distance of this sample to each of the training samples, and then we have a look at the nearest neighbors. So in this case we have a look at the three nearest neighbors, so these ones. And then we choose or predict the label based on the most common class labels here. So we have two blue classes and one orange class. So this then will be a blue class. And this is the whole concept of the KNN. And what we also have to know is, in order to calculate the distances, we use the Euclidean distance. So in a 2D example, the Euclidean distance of 2 points is defined as the square root over, and then we have for each feature vector component, we have the squared difference. So we have x2 minus x1 squared plus y2 minus y1 squared. So this is the Euclidean distance in a 2D case, and in a more general case the formula is defined as this. So it's the square root over the sum from I equals 0 to n, where n is the number of dimensions, and then we have the sum over each component, and for each component we calculate the squared distance or the squared difference. So this is the Euclidean distance, and this is all we have to know in order to implement the KNN. So let's start, and first let's define a class called KNN, and this has of course an init method. So init self, and this will get a k. So this is the number of nearest neighbors we want to consider, and this will also get a default value. So the default is 3. And in the init, we define the init. So in the init we simply want to store the k, so we say self.k equals k. And then what we want to implement here, and here we want to follow the conventions of other machine learning libraries, for example the scikit-learn library. So we have a fit method. So this will fit the training samples and some training labels, and this will usually involve the training step. So we want to implement this one, and then we also want to implement a predict method. This also has self, and the predict method. So here we want to predict new samples. So these are the methods we want to implement. And now, before we go on, first of all, let's have a look at how our data looks. So what is this x and this y? And for this I wrote some test script. So here I used the famous iris data set, so you might have heard about this already. So I can get this from the scikit-learn module, and then I will generate some training samples and some test samples and the associated training labels and test labels. So let's first have a look at how this training samples look. So we want to print the shape of this one. So this is a NumPy ND array of shape 120 by 4. So 120 is the number of samples and 4 is the number of features for each sample. So for example, let's print the first sample. So this is 4 features in it. So this is how our training samples look. And now let's have a look at our training labels. So this is a 1D row vector, also of size 120. So for each of our training samples we have the label for it. So if we print this, then we see this will be a 1D vector with only one row. And now what we see here is we have labels 0, 1 and 2. So this is a 3-class problem. So let's also plot this. And now, for example, what I plot here is I only plot the first 2 features, so that we have a 2D case. So this is how our data looks. So we have 3 classes, red, green and blue, and yeah. So this is how our data looks, and now we can continue by implementing this. So in our fit method, so in the KNN algorithm, this doesn't involve a training step. So what we do here is we simply want to store our training samples and then we can use them later. So we can say, so let's store them. So let's say self, and then we call this x train equals x, and self y train equals y. So this is all for our fit method. And now for our predict method. So this will can get multiple samples here. So we can see this because we use a capital X for this. So this can have multiple samples. So we can write a little helper method. So we want to do this for each of the samples. We want to say we want to get the predicted labels equals, and then we write a helper method that we call underscore predict, and this will only get one sample. So here we use list comprehension. So what we want to do then is we want to call this self predict with one sample x, and then we want to do this for all of our samples in our tests samples here, so for small x in capital X, and then this will be a list. So let's convert this to a NumPy array, and then this is our predict method, and of course we have to import NumPy, so we say import NumPy as NP. And now how does our underscore predict method look like? So now again let's have a look at the figure here. So what we do is we want to calculate all the distances, and then we have a look at the nearest neighbors and the labels of the nearest neighbors, and then we do a majority vote and choose the most common class label. So let's write some comments here. So first of all, we want to compute the distances. Then we want to get the k nearest neighbors, so get k nearest samples, and we want to get the labels, and then we do a majority vote, so we want to get the most common class label. So let's do this. So let's say distances equals, and now, as I said, we use the Euclidean distance here, so let's define this, and we want to define this as a global function. So you might want to write this in a separate file or call this in some utility class. So here I will simply do it in the same file. So I say Euclidean distance of two feature vectors, so let's say x1 and x2. And now again, let's have a look at the formula. So this is the square root and then the sum over each squared distance. So we have the square root, so we can say NumPy dot sqrt, and then we have the sum, so we can use NumPy dot sum. So this will calculate the sum for over each feature vector component, and here we have the squared difference, so we can say x1 minus x2 to the power of 2. So this is all we need, and then we want to return this, of course. And now in our predict method, what we want to do is we want to calculate the distances of this one new sample to all the training samples. So we also use list comprehensions here, and we call this Euclidean distance with our new test sample. So, and then to each of the training samples, so we say small x train, and then we want to calculate this for x train in capital or in self dot x train. So now we have all the distances, and now we want to get the k nearest samples and the labels. So what we do here is we sort our distances, and we can do this. So let's call this the k indices, and here we use NumPy dot arcsort. So this will sort the distances and will return the indices of how this is sorted. So here we call distances, and this will be an array, and we only want to have the k closest samples. So let's use slicing here, and let's start at the beginning, so 0, or we can omit this, and this is goes only until self.k. So this will be the indices of the k nearest samples, and now let's get the labels. So we get the k nearest labels equals, and here we also use list comprehensions, and then we get the label of each training labels with this index. So the index I, and then for I in k indices. So now we have the labels of our nearest neighbors, and then we use a majority vote and get the most common class label. So let's call this most common equals. And for this we use another Python module. So we use the counter module. So we say from collections import counter, and then we get a counter of the k nearest labels, and then this is a method called most common, and we only want to have the first or the very most common. And now let's have a look how this looks. So if I comment this out and let's write a short example what the collections or the counter module will do. So let's say we have a list A equals, and this is some values in it, so 1, 1, 1, 2, 2, and then some other labels. So also from collections import counter, and now we get the most common equals. So we create a counter of this list and then one most common. So let's print this. So I have to close this first, so let's run this again. So this will be a list, and then we have a tuple of the most common items. So for example, if we, in this case, we want to have the one most common item, and this is a tuple, and the first item here is the most common item, so this is 1, and the second item is the number of times this is in our list, so 3 times 1. So for example, if we use 2, then it will also put in the second most common items. In this case it is 2, and we have 2 times 2. So we only want one most common. So as I said, this is a list. So in order to get the first item, we use the index 0. So now we have the tuple, and now to get the actual items, again we use the first index, and then we have 1. So here we have to do the same thing, and we want to return this. So let's return most common of index 0 of index 0. And this is all our implementation of the KNN algorithm. So let's try this out. So let's, in our test example, we already have our test file, we already have our training and test samples. So let's use our KNN class. So we can say from KNN import KNN, and then create a classifier. So CLF equals KNN, and so let's use k equals 3, and then we want to call the fit method first. So we want to fit our X train and the Y train, and then we get the predictions, and this is we do this by calling clf.predict, and then we want to predict our test samples, so x test. And now let's calculate the accuracy. So accuracy, so this is defined by how many of our predictions are correctly classified. So this is the, so here we use the sum, and here we write predictions equals y test. So for each prediction that is the right or the same as the correct label, it adds 1, and then we divide this by the number of test samples. So we divide this by lang y test, and let's print our accuracy and see if this works. So yeah, in this case it's 1.0, so all of our predictions are correct. So let's use another number of neighbors, so k equals 5. So usually you want to use an odd number here. So let's run this. Oh, sorry. So in this case it's 0.96. So not as good as with 3 neighbors, but also very good. And yeah, we see that this is working, and this is our whole implementation of the KNN. And yeah, I hope you enjoyed this tutorial, and see you in the next tutorial. Bye.